In this video, I want to look at two example problems that involve permutations and combinations, but are in the context of a more difficult real-world problem. So let's just launch right into the context of the problem, and then we'll work our way from there. Four students are chosen randomly from a group of 12 for the titles of president, vice president, secretary, and treasurer. Now, if we stopped right there, and we actually will include this as part of our answer, and we wanted to know how many different ways could students be chosen for those four roles from the group of 12, hopefully you would understand that in this case, order does matter. Because the roles are specific, order does matter. So we're going to be using a permutation instead of a calculation. And based on the previous two videos and your study, we already have the tools to be able to answer that question. But this problem throws a little twist at us and adds something extra. So four students are chosen randomly from 12 for these four roles. And we want to know, what is the probability that Daniel will be chosen as vice president and Rachel will be chosen as president? So we're taking two people from the group, Daniel and Rachel, and we're saying we actually want to know the probability that specifically Daniel will be the VP and Rachel will be the president. So a more difficult problem. So when we're talking about probability, we need to back all the way up to our definition of how do we calculate any given probability in a general sense. Probability is calculated by the number of favorable outcomes that can occur divided by the total number of outcomes. In this specific problem, the total number of outcomes is actually easier to think about and to calculate. The total number of outcomes is the total ways that students can be chosen for the four different offices of president, vice president, secretary, and treasurer. That is simply our permutation of 12 students being chosen four at a time where order does matter, or using the shorthand that we've learned, 12P4. 12P4 is actually a pretty large number. It turns out to be 11,880. So again, to understand that number in the context of the problem, there are almost 12,000, 11,880 unique ways that four students can be chosen from a group of 12 for these four specific roles. So that's our total outcomes. If we go up here, we can go ahead and fill that in our denominator of our probability calculation. The more difficult thing to calculate is the number of favorable outcomes. So we need to at first even consider what does that mean. An outcome for us is only going to be favorable if Daniel is the vice president and Rachel is the president. You may be tempted to think that, well, there's just one favorable outcome, so we just put one in the numerator. But if you stop and consider, is there only one way that Daniel can be the VP and Rachel can be the president? And the answer is no, because there are still two other roles, secretary and treasurer, that need to be filled. So Daniel could be the VP and Rachel could be the president with these two people as secretary and treasurer, or another two people, or another two people, or another two people. So we need to figure out the total number of different ways that Daniel can be the VP and Rachel can be the president. So the number of ways that he can be the VP and she can be the president, if we just stop right there, it's true, it is one. But then, once that is established, we still have 10 students that need to be chosen for the other two offices. So I get 10 because I'm taking Daniel and Rachel out of this 12, and then I still have 10 students that need to be chosen for the remaining two offices. Since order does matter, because secretary and treasurer are two different positions, the number of ways that 10 students can be chosen for these two offices is just 10P2. 10 taken two at a time where order does matter. 10P2, if you calculate that out, is 90. So again, we need to stop for a second, make sure we understand that number. If Daniel is the VP and Rachel is the president, and we assume that that is true, the remaining 10 students can be chosen for the other two positions in 90 possible ways. So there's actually 90 possible ways where we could get our favorable outcome of Daniel actually is the VP and Rachel is the president. But the overall question that was asked to us at the start of the problem is, what is this probability that this will happen, that Daniel will be VP and Rachel will be president? We now are ready to actually calculate our answer. We know that there's 90 ways that that could happen, but it's out of a total of 11,880 ways. And if you do that division, you end up with the decimal of 0.008 when put in terms of a percentage is less than 1%. It's actually 0.8%. So, less than 1 out of 100 times this is going to be true. And you probably could have guessed from the context that this percentage would be low. Now, I want to change one slight thing about the problem and do a similar problem using almost the same context with one slight tweak, and I want you to notice how the problem goes from a permutation problem to a combination problem. So let me do that. 4 students are still going to be chosen from a group of 12, but instead of giving them specific roles, I'm now just going to say that they're chosen for a committee. So 4 students are chosen from a group of 12 for a committee. I'm not going to differentiate between the people on the committee. And then I'm going to ask, what is the probability that Daniel and Rachel will be on the committee? Now, hopefully, you already have a sense that as we calculate out this probability is going to be much, much higher. Because instead of Daniel and Rachel having to occupy very specific roles of vice president and president, now they just have to be on the committee. Furthermore, since we're just forming a general committee, we're now establishing that the order does not matter. Okay, think of it this way. A committee with Daniel and Rachel is the same thing as a committee with Rachel and Daniel. The order of the members, the way they're listed in the committee, the order doesn't matter. So what that signals to us in terms of the solving of the problem is that we're going to be using a combination and not a permutation. Now, most of the same things still apply here. We're doing a probability problem. We want the favorable outcomes divided by the total outcomes. Let's erase our previous calculations here, and I'm just going to keep for reference that our previous answer to our last problem was 0.8%. We want the favorable outcomes divided by the total outcomes. Our favorable outcomes in this problem would just be Dan and Rachel on the committee. Okay, so let's first answer that question. How many different ways can Daniel and Rachel be on the committee? Well, we're going to do a similar thing as we did in the last problem. If Daniel and Rachel are already on the committee, and we're assuming that's true, we still need to select 2 more people from the committee. So we're selecting 2 people from a total of 10 people remaining, but different than our previous problem, the order now does not matter. So instead of 10P2, we're going to be examining 10C2, which is going to be 45. There are 45 different ways that Daniel and Rachel can be on the committee. And those 45 come from the fact that we're still having to choose 2 other students to be on the committee with them. Now we have to answer the question, how many total ways can the students be chosen for the committee? And that's as simple as changing this P to a C. Because in general, when we're choosing the committee, we have 12 people. We're choosing 4 at a time. Order doesn't matter. That's 12C4. It's going to be a lot lower than the 11,880. This is actually 495. So going to our probability, 495 total possibilities for the committee, and 45 of those 495 are cases where Daniel and Rachel are on that committee. If you do this division, you will find that this is 0.09 or 9%. So there is a much, much higher likelihood that Daniel and Rachel will be on the committee than Daniel and Rachel would occupy the specific roles of vice president or president. So when you're exploring problems like this and you're trying to figure out the probability or the chances that something will happen, what you need to do is first determine, am I using permutation or am I using combination? And then if you're doing a probability, you have to nail down what are my favorable outcomes, how do I describe those using a combination or a permutation, what are my total outcomes, then do the division and come up with your decimal answer or your percent answer.